Part 3. Question 12. Use the figure below to answer the following questions. A. How many valence electrons does the atom of this element have? Well, I'm going to look at the outermost shell. The outermost shell has two electrons. But I want to make sure. I want to find out what element this is. So I'm going to count the number of electrons. We have 8 and 8 is 16, 17, 18, 19, 20. This is element number 20. I don't know what element 20 is, so I'm going to look at my table. Number 20 is calcium. Calcium is in the second group. That means it has 2 electrons. They're in the valence shell. So it has 2 valence electrons. What's the electron's dot structure? If I know that it's calcium and that has 2, I can do this. Calcium having 2 valence electrons. Now, even though energy was added to remove an electron, from which if enough energy was added, if enough energy is added, which electron would bounce off? The outermost electrons would bounce off, so the valence electrons would come off, and that is because since they're farther from the nucleus, they're less attached to the atom, and it would just be easier to kick them off. Alright. What's the ground state electron configuration of each of the following atoms? It's asking us to use noble gas notation. So the way you do noble gas notation is, let's do example, selenium. So selenium is somewhere around here. Selenium, there it is. Okay, in noble gas notation you have to go to the noble gas before the element. So the noble gas before the element is arsenic. I will put arsenic in brackets. By putting arsenic in brackets, I'm stating everything up to arsenic holds true. So I don't have to put 1s2, 2s2, 2p6, 3s2, 3p6. Did I say 3p6 twice? I don't know. Alright, I'm just going to put arsenic is there. Argon is there. Wow. Argon is there. I'm thinking about the last problem. So AR for argon, not arsenic. And then I'm just going to complete the table to selenium. Can you tell I'm doing these last minute? Okay. So we have argon here as the noble gas. Then we're going to continue to selenium. So I'm going to do 4s2 because both potassium and calcium are filled in. Then I'm going to go to 3d10 because all of these are filled in. And remember, when we go to d, we subtract 1. So instead of being 4, it's 3. 3d10 and then 4p, 1, 2, 3, 4. So there we go. So it's parentheses argon, 4s1, 4s2, 3d10, 4p4 would be the noble gas configuration of selenium. I apologize for calling argon arsenic. And you guys can hopefully do the next two. Number 14, what's the highest energy level N that was occupied by the following elements? So that's just asking for the number on the side. So this is 1, it's 1, 2, 3, 4, and so on. For tin, we have tin is here. You can't see it. Tin is here. So we have 1, 2, 3, 4, 5. So it's 1, 4, and 5. And let's write the electron configuration for each element described. So an element that contains 8 electrons. If it contains 8 electrons, then it must be oxygen because oxygen is number 8. Right? And we've done the electron configuration of oxygen, so you should have it in your notes. And what contains 14 electrons? Well, 14 electrons is silicone. Silicone's pretty cool. We use it in computers. So number 14, I would have to do 1s2, 2s2, 2p6, 3s2, 3p2. And I'm going to see some 1, 2, 3, P, 1, 2. That's silicone. Alright. Hopefully this helps. And if you have any questions, please ask in class.